Hey guys, so let's carry on with this electricity effect, and the first thing I want to do quickly is sort out my problem source here. So I wanted to have a wave of electricity that had quite a lot of points, and then that wave was followed by just a few extra points that travel along the surface, but it looks like I've got the opposite. And I'm just blanket deleting by ID here, and I'm keeping 1 for every 1,000 points. But it seems to only be affecting our high density point cloud. So I'm going to come back here to my source and have a look. So here, this is the same. If I move my delete over here, it's the same. So I think what I could do is maybe offset the, here's my ID offset. So let's try to boost this higher. Oh, that's completely different. So let's see. So now it is picking up the points. So I think 1,000, what was I on? 10,000 wasn't enough to make sure that these IDs were completely unique compared to these ones. And I mean, yeah, there's still 35,000 points over there. Still 126,000 there. Oh no, 600. And 35,000. So I guess this just makes sure, just go crazy on this ID offset value here and make sure those points have completely unique IDs. And then there'll be a chance for them to be included over here. So that looks better. So what else can we do? Well, let's jump back over to the 2D effects thing here. And I'm not going to bother with, if we look at this anatomy of lightning, hooks, too complex for the moment. Loops we can do. We've got noise. Different thicknesses I'm going to avoid for now because that looks a little bit 2D and I want the lightning to be quite thin anyway. And then branching. So I think these kind of loops over here we can sort of replicate in a cheap way, and then we'll add some branching as well. So let's start with my quick method of adding detail. And this is actually kind of important because, let me choose a good frame. If you render out an electrical effect like this, for one, it might look okay in a still frame, but once you render the sequence, it can look very plain and boring and something not quite right. So we do need to make sure we render with motion blur on, and I've got a few tricks for adding a good looking velocity vectors to electricity, so we can do that. And that plays particularly nicely when we add a bit more detail to the arcs as well. And so the quick way to do that is just take the point where you've got the mask, duplicate that noise, and merge it back on. So now you can take the second noise and just mess around with the values here. So let's say go a little bit higher frequency, maybe change the offset a little bit. maybe the amplitude as well. So basically what I want is a secondary arc for each one. And then we can take let's take this color and alpha here and multiply that down as well. So we can say 0.25 on those, and that way we get some very low intensity lines. Maybe that's a bit too low. For every main line, we have a very subtle secondary line that's basically filling up the same space, but it has a slightly different noise. So it looks pretty simple when we're looking at it here, but once these lines have motion blur and they're rendered with thickness, then the fact that those secondary lines are slightly less thick and slightly more transparent actually just makes it feel like one much more detailed line than having just a simple duplicate. So it's a very quick and easy way to add extra detail, especially to the rendered electricity. So something like that will be good. And then if we merge this back on, there's also one final step that I usually do, and that's just to make sure everything is neatly colliding with the collision object. So I'll put down an attribute transfer. Transfer our position from the drone to the arcs, match P. So now it's essentially raying it down, so we don't want that. Just increase the samples here, and then just very subtly, just off the distance of the drone, we can force everything to move down as a collision. So if we look at some of these areas here, we just want them to definitely touch. So if they're within a certain radius, we can kind of make sure that they form a good collision value there. So it's to tidy up those ends, and also if there's any pieces of electricity slightly moving inside, then they can also be attached to the surface of the drone. So it's a little bit of cleanup, just to make sure everything is neat. So I'm pretty happy with that. So let's take a look and see what we can do about branching. So let's take the end result, because here we want to take our main lines and use them as a source. So first thing I'm going to do is bring it back up here and remove any of the darker ones. So let's say any blue less than 0.5. So we're just keeping the brightest ones. And then we can take our initial points over here and let's have a few more. And I'm just going to attribute transfer the position of these source points to the location of our brightest arcs. So now we make sure that wherever there's an arc, there's source points on those lines. So that's pretty simple. And then I can basically I'm going to put this color over here so that it affects both of them. And then we can just copy and paste things that work in this setup over here into this one. So we want this P scale and this line copy over here as well. but we obviously want the lines to be a little bit smaller. Let's just reduce the whole line. And I'm actually going to go with just 2 points. My idea is to do the same thing we did with the projection lines. So here we have 2 points, and so we can group point 1 into a group called end. And that way we know that our source of the line is directly attached to an arc. And then we want to take the other side of that line, so the end group, and ray it onto our drone. So if you see there, obviously it's slightly confusing with the internal ones. But if there's an arc on the surface, we're copying some points onto it and then raying the other end of that small line onto the drone. So I'm guessing there's an arc here that we can't see. So you can see it a little bit more clearly there. So that's branching. And just double check this ray is working. Yep. So that works. And what else do we need? We don't really need that mix. We do need a resample. I'm going to grab it from down here and actually take the noise as well. So we'll resample those and get our curve view. Then we'll add some noise. Maybe drop down our amplitude a little bit. Bit of a higher frequency. So something that looks good. And what else do we need? I don't think we need the secondary noise for these because they're very small. We take this attribute transfer maybe. Let's go a little bit less. And if I merge these all together, let's see what we've got. Okay, so we can see here we have a main arc, and then if I merge this one on, we get this branch. So that's working fine. That actually looks really good. So we should see that in a few places as these arcs travel along. So it's a pretty subtle element, but it'll definitely add something. You can see here the shape is just, it's not lines anymore. It's got some definition. So we pretty much tackled both of those aspects here by using multiple noises and just merging it back together. It's actually a very quick way to add detail to electricity. And then here a quick branching setup, which basically we've just copied and pasted things from what works and put smaller lines on and copied them onto the brightest arcs. So let me kill this and let's have a look at meshing this. So I'm going to put down a poly wire. And let me save before I do this. We want to use alpha, because we know the alpha is changing over time, and we want the thickness of the wire to change over time as well. but we need just a tiny value. So alpha times 0.0005. Wow, that is tiny. Okay, so because some of the alpha is 0 as well, I'm going to just add another 0.001. So I'm just messing around here, and obviously I can change these values in the render as well. That's way too thick. So it doesn't need to be thick because they're going to be pretty bright, but depending on the thickness, we might have issues with sampling a geolight with this effect. So I'm going to leave it like that for now. Let's put down a color. And we can just say CD as our ramp and just choose a nice blue here. And I'm not seeing it, I don't know why. Oh, there we go. It's because I think I have to facet this polywire. It's got something to do with the normals. So I'll just post compute normals here. So there's our color, but there's so much going on here, and there's so many lines that are actually have a 0 alpha. So that's causing a problem. In the render we'll just see this, but in the viewport we're seeing a lot of other stuff going on that we shouldn't see. So just to visualize this, I'm actually going to switch off or remove any super dark ones. So that's a bit easier to see. And then we can visualize this on the drone itself. Just add a little bit of thickness there. And then let's introduce our branches as well. So I'm just going to use a duplicate polywire so that we can make them slightly thinner possibly. And I can even say, let's leave it the same and then say multiply by a random ID. Say, just go with 0.3 and 1. So here at least random one of these branches will have different value thickness. And we can merge these two together over here and run it through our color. So something like that, where we have the main branches being slightly thicker than, or the main arcs being slightly thicker than the branches. And the branches now have a slightly random thickness as well. So that can be our visualizing, and what we need to render is this. And then we also need to use something for a geolight. So I'm going to use a different color. Because in general, you don't really want to use a ramp on the color for a geolight, because it is inheriting that color, and that means that it has to sample for each change in value. So you end up needing a lot more samples to manage a light like that. So instead I'll just apply a blanket color to our arcs over here, and we can see how that looks in the render when we do it. For now, I'm going to just flip book this. I'll maybe make this a little bit thicker for the viewport. So I can flip book that. And then we'll come back in the next video and start messing with the render. As I said, we need to add velocity attributes so we can get some decent motion blur off of these arcs to make them really work once we have a rendered sequence. Basic shader, which we've already copied from the projection lines. And once we're happy with the motion blur and the general look, we'll set up a geolight for these arcs and a render pass for the drone as well. And then just render everything out. And the rest of this effect will just be bringing in these layers in comp and seeing if there's anything else that we need to change. So these are now very thick for the visualizing. So except for being too thick, I'm pretty happy with this. There's actually a few spots there where I can actually see a branch, which is good. The motion feels quite nice and snappy. It's not too random feeling. You can kind of watch one and see how it progresses. And you can also just follow these arcs and understand the motion of that propagation without even needing to see it. So you can tell they're starting at the back and they're moving to the front. And then you can also see that secondary wave. So here's our first wave, and here come a few more to follow, and then it's done. And we're getting some nice shapes in there as well. If I come to the front, the secondary wave over here, we're getting some nice little connection lines, and also down here. So yeah, I think that looks good. Let's come back in the next video, shade these, set up a light, and then we'll render all the passes. So I'll see you in the next video.